Okay, so we're looking at how we're actually forming an image and what it's going to look like. So we've progressed from just drawing a diagram and knowing where the light's going to go with a concave and convex lens, and now how do we see the image? So from this position, where the blue dot is our focal point for this particular concave lens, we're going to draw two rays to identify how we're going to see the image as it's reflected. So we're going to draw our first ray in line with our height of our object, and then that line is going to pass straight through our focal point. And we saw this happen when we looked at our ray diagrams before and using our light boxes. Our second ray is going to hit our principal axis, or the point at which it's 90 degrees, and it's going to reflect off on a similar angle so that the angle of I is equal to the angle of R, because that's just at right angles. Now the point that these two rays meet up, that's our focus area. This is how we're going to be able to see an object. So if we were to have a look at what an object would look like at this point, our object would be inverted and it would be enlarged. And that's the image that we'll see when our person is further back than the focal length. So what happens when our person moves forward? As our person moves forward and closer to our focal point, let's place our person on our focal length. We have to draw some new arrows. So our first ray, which has come at the height, is going to still travel through our focal point. And our new ray, which is going to hit the principal axis, is going to rebound so that I and R are the same. Now, as we can see, the light rays are actually parallel to each other, and they're never going to meet. Now in this instance, there's no focus point, so our vision for this is going to be blurry or non-existent. It's hard for us to distinguish a picture. The last one that we need to identify is what happens when our object is in front of the focal length, or we're looking close at the mirror, and we're going to move our object in front of the focal length. At this point, we'll once again draw our rays from the head through our focal point, and from our top of our image to our principal axis. And as you can see, our rays are getting further apart. So for us to look at this, we're going to have to look at a virtual image. And we'll just connect this last one up. The same line. Along the same path. Okay, and we have an intercepting point here. So if we copy our person, we place him over here. Our person is now going to be enlarged. It's going to be virtual because we're going to be looking at it through the mirror, and he's going to be upright, so he's no longer flipped. Okay, now what happens when we've got a convex lens? So we're going to do the same thing as we did with our concave lens. We're going to draw a couple of rays coming from our height, representing the height of our object, and we're going to connect up. We're going to show how that's going to be reflected. Now we saw with our light boxes that the light reflected was away from the other rays, and so they're not going to be intercepting. Our next ray, going from our height to our principal axis, and that's going to be reflecting away so that I and R are going to be equal. Now, because these rays aren't going to intercept, it makes it hard for us to form an image. So the image that we're going to be seeing is going to be virtual. So if I extend my principal axis all the way through, I'm going to need to connect my lines up. So if we take a dotted line and pass that straight through our mirror, and we make it dotted so that we know it's virtual. At that interception point with the principal axis in there, that is our new focal point. I'm going to mark that with a blue dot. My next line that I have to continue on is this one. Now I know that this ray represents the height of my object, so that corresponds with the height, and my principal axis represents the feet of my object. So this is the feet of my new stickman. So if I place a new stickman that fits into that area, we'll notice that my image has been diminished. It's still upright, but it's virtual because it's inside the mirror. If I compare that to my original image, it's shrunk by quite a bit. But you might be thinking, what happens when my image is forward of the focal line? So let's lead a couple of rays. I'm going to bring my stickman in front of my focal point. And now I need to include a couple of new rays. So my first ray is still at my height, and that's not going to change. My next one is going straight to my principal, and that's going to be reflected away. A dotted line to represent the virtual image, and we'll notice that my new height is slightly higher than my old height. My new stick figure who's going to fit into these dimensions is slightly bigger than my last one when my image was behind the focal point, but he's still diminished from my original if I put him